section 4, example 4, we're going to use synthetic division. If you look at your notes, the previous 4 notes of or slides of before this example kind of show you how to do synthetic division. Now we do synthetic division. It's a faster way to do it. Once you do it a few times, you kind of understand the method. But we have to divide by a degree of 1, and the lead coefficient has to be a 1. And I'll show you in the next example if it's not a 1. But it does have to be a degree of 1. So then we don't have to do long division like we did in the last 2 examples. So what you do is you look at your coefficients, and then you just list those coefficients in order, and it has to be 3, your largest, second largest, third largest, all the way down to your constant. If you're missing one, so if there was no, say, x, that wasn't there, I would have to put a 0 in that spot. Okay, so I'd have to put a 0 in that spot. So you start with the degree, the largest exponent, and then you go in descending order from there. And if you have any missing, you have to put a 0 in that spot. Okay, and then you put this little bracket here, nice like that. I think I put mine actually down here. So you can do whatever you want, doesn't matter. I usually put mine down here. So what you're doing is what's going to go in here in this little bracket is setting what you're dividing by 0, and then solving for x. So if I subtract 3, I get x equals -3. And so that's what's going to go in this little box here. I actually make this a box instead of just a nail. And so I put in -3 in there. Okay, and then so my first row is my coefficients. The second row, I'm going to always start with a 0 here. Okay, and then I'm going to take this first row and I'm going to add the second row, and it's going to go underneath this line. So you got to put a line here. Okay, and then this little bar comes always at the end, right before the last one. Okay, so then I add these. So 3 plus 0 is 3. And then whatever lands on the third row, I am going to multiply by what's in this box here, or what's in this L. Okay, so -3 times 3 is -9. Now I'm going to put that answer in the next column in the second row. So second row, and this in the second column, I want to put -9. Now I'm going to head and add those 2 rows, first and second row, and I get -11. And then I am going to, whatever lands in the third row, I'm going to multiply by what's in the box. So -3 times -11 is +33. I'm trying to be color coordinated here. And now I'm going to add those first row and second row, and I get -20, color coordinated. And then whatever lands on the third row, I multiply by what's in the box, so that'd be 60. And then I add those, again, color coordinated. Come on now. And I get 0. And so that's my remainder, is remainder of 0. And so what I did is, because I divided by a degree of 1, right, so this is a degree of 3, and I'm dividing by a degree of 1. X cubed divided by x to the 1 is x squared. So that means this first one is an x squared, and then I just go in descending order. This would be an x, and then this would be my constant, right? And then here's my remainder, kind of like we did in example number 3. Okay, so there is my answer to this division problem, is 3x squared minus 11x minus 20. So something to think about is, can you describe a method you would use to check your answer? So if this is my answer, how would I check that that is correct? So here I'm dividing, right? So kind of like 500, do something divided by 5, right? So the answer I know is 100. How do I check that that answer is 100, right? What would I do? Same thing here. What would I do to check this answer is correct?